Hello everyone, April the 3rd, Saturday. Alright, let's get into this. Well, we didn't do it yesterday. We didn't succeed yesterday, so let's hope we have better luck today. Alright, take a look. What do we have? Longest valid parentheses. I might have done this before. I think I have. Longest valid parentheses. Alright. Given a string of left and right parentheses, find the length of the longest valid parentheses substring. Stack. Yeah, definitely stack. How'd you count? So stack, we push in, out, and out. We can pop, right? Pop on top, and that's a pair. So we are going to count, right? And then this is not valid. We push, pop, that's 2. Push, pop, that's 4. And then push in, and that's it. And this one is 0. Well, is that it? We just push and pop? Yeah, I guess that's it. Let's try it. Give it a shot. Man, I think this probably, if this is what I think it is, and if we pass like this, then this is probably an easy question. We have regressed so far to only being able to solve easy questions. That is so sad. So sad. Well, we're gonna build it back up. That's fine. It's just a little bit obstacles that we have. So we're gonna have a stack. For I'll have a result 0 for lettering S. If letter is this, then stack dot pen letter. Else, if it's not, then we simply just pop, right? Stack dot pop, and every time we pop, we can say res plus equals 2, and then return res. I hope this one is not 100% sure, but yeah, if you think about it this way, it does look like an easy question. We can create some test case ourselves. That's what before, right? And this should be 0. Yeah, it's definitely an easy question because I can create test case myself. This one should be 6. And no, there's no like rule on how I'm creating this. I'm just writing it. Oh, let's try their one. This. That's also 4. One more. Okay, let's go one more. 2. Okay. This one is longest. Try it. Pop from empty. Ooh. Left stack. Okay. At least all these pass. Let's try. See if we have good luck today. Submit. Pending. Wrong answer. Oh my god. Nope, it's not this easy. I think we can figure out. Maybe it's like this, right? Hold on. Yeah. So like what? Like if we have 2 valid, but then they're separated by invalid, like this. Yes, like this. What is the value of this? Otherwise, it is too easy. I will give 4, but I think this should be 2. Right? It should be 2. Oh my god. Okay. Yep, that is the one that we got wrong. So should be 2, but I give it 4. All right. So basically, we have to notice when it breaks, right? So we keep going, pushing, popping, right? And then every time we push a new one, what are we saying? We're saying is the longest valid parentheses, right? So in this case, we push and we pop, that's 2. Then we push in another one, and then we push another one, then we push another one, then we pop. So how do we know that this is the second one, this is not, this is different from the first one? Well, it's not because say in the middle is not well forming. So it is not well forming if we have unmatched, right? If we have unmatched, right? And then when we pop it out, and then we'll see there's still something in there, right? If there's something in there, that means it's unmatched. If it's nothing in there, that means, let's see. So, and also, if we do this as a right parentheses, I think this is the same, right? It should also be, if it's a right parentheses, it should also be 2. Yep, both shall be 2. Okay, so basically we need to identify when it is breaking. Okay, so I think about this case. We push and pop, and then the stack is empty. Now the stack is empty means the stack either is empty, or if we do this, like if we have an empty right, that's the indicator. If an empty right, like we have a right but there's no left in the stack, that means this is a separator, right? We are not forming a string, so we should reset the rest. Yep, that's a good one. How about left? Well, if it's left, so we do this, and we're pushing a left. We can now know because it might come a right at the end. So how do we know? Okay, so every time we have a well formed, and if there's a left in there, then we suppose, like if there's a unmatched left, we suppose there is possibility of adding more to it, right? If that's the case, then we'll go left, right, pop in, that we put in the current. You say current, and then we get another left, push in. It's still current because we might have a right, and then coming in another left. This is an easy case. This is a little bit more complicated. Or maybe we can do it. Have you ever thought about doing a reverse? Right? We pop, which means if we have a left, then that's bad. So can we run it 2 times? We'll go left, right, and then right to left. And then from left to right, the deal breaker is a right parentheses. Every time we see a right parentheses, that's by itself, and that's a separation. And if we go from right to left, every time we see a left parentheses, that is a deal breaker. So we run it both times, and then we take the one with the minimum. Because the break is unmatching, right? Break happens if it's unmatched. It's unmatched. If it's matching, but I just realized we can have a situation like this, which is also make things complicated. So we have this, right? And then our left parenthesis here. That is, no, that is good. No, that is not good. No, that is good. No, wait, my eyes is playing game with me. This is what we want. That's just like the front. So we can do anything, right, in it. We're going to put the right parentheses anywhere. Like if we do two right parentheses, two right parentheses, right, and here we can identify it as well, right? If right parentheses here, right is the same as here, and we can do. And so the question is, if we have left and right, now this is not matching. And if we do a left parentheses here, like this, yeah, and it's matching. Yeah, as long as the same number of left and same number of right, and then they can be anywhere in it. And the left goes before the right, and then it's always a matching. So in that case, yeah, we just need to count the right parentheses. Kind of whenever there is a single right parentheses that shows up, and then that means we have a break. Yeah, there's a right but without a left to match it, and that is a break. So like until this string, until this right parentheses, we cannot continue forming. So I am going to try to run it 2 times. So we're going to run it 2 times. This is the first time. We're going to have res, and then we're going to have current, right? So we're going to say res1. We're going to say left to right. And current is also 0. And we have this. We append. Else, right? Else. Then we go if stack. If stack. Then stack pop. That's a good case. Yeah, if stack, then it's a good case. And then we say current. Do this, and current do this. Else, if there's no stack, and that's a break. I'm going to say res this equals max res this current, and current return to 0, right? This is from left to right. And then we're going to do exactly the same, but we're going to try right to left, right to left, current still, and I want to get a stack as well. Now it's different, so we're going to say, I'm going to reverse it, right? Reverse it, and after reverse it, we're going to say, we're going to call this. If it's a right parenthesis, we pack. Else is a left parenthesis. Again, if we have stack, we pop, we do this. Otherwise, right left equals right left, and then current 0. And then we're going to return the minimum of the res this and the res this. All right, let's see if these 2 passes. Oh, they're all not pass. Oh, why is that? Why does that? Oh, the minimum. Wait, the minimum. They both should be 2. Okay. What is the issue here? Append and else if stack.pop current plus 2, and this shall equal to this. Yeah, what was the problem here? Let's print res 0. What the hell? Print stack. Yeah, it has something. Let's print current. 0, current is 2. Oh, we have to do this at the end as well. Yeah, my bad. I forgot to do this. So if this all at the end, we have to do it. And this is the same. At the end, we have to do it. Then we're right. Okay. Now let's give these a try. How we pass. We go like 2 times from front to back, from back to front. Let's give this a shot. Run it. Alright, wrong answer again. Oh man, there's another situation that I have not considered. What could that be? What can that be? I say I separate these. Let's separate again. Like that. Do we have the right answer for this? Still, I don't want to look at it. And just run a test case. Okay, like this. Do we get the right answer for this one? Yeah, this is right. What could it be? All this? No. All this? Yeah, we're just trying. I see. Huh. What could the error be? Oh. Okay, so it's like we have this, and then what? Like separate it? Separate it? I don't know. Just trying different things. See how it goes. I'll probably have to go check what was the wrong answer. Anything that you haven't considered? Oh. just trying different things. These are all the same thing. Maybe it's just like deeply like this, right? And then we do this trick. Maybe that is the case that we got confused. Nah, that's one correct as well. Yeah, that is correct. If I do this, think that one should be correct as well. All right. I don't know which test case we fail. I want to take a look. Which test case that we fail. Should have checked earlier. Oh my god. We got a hard one again? Oh, I did this before. My. Must be a hard question back then as well. Yep, 3 hours back then. Alright, we submitted twice. Let's just check. Oh, we passed a lot. We passed a lot. Man, LeetCode is doing something good. It's alright. It's not that easy, huh? Nope, it's not that easy. Expect 4. Okay. Let's check. Let's check. Alright. What happened here? So it's going to be 1, 2, 3, 4, okay. In my case, after the first run, right parentheses means we're gonna start new, right? Right parentheses else, we're gonna start new. So I start new. These, so I got 2, and then we got right parentheses start new, and then we got 4, right? And then we don't know, got right, left, and right, and when we come out, we do it. So pop. Oh, I think it's because at the end, you have to check. You have to check, right? You have to check. How do you check though? If we have the left parentheses, right? And we don't know. Okay. Okay, I see the problem because no, it's fine because on the right side I should they have the same construct. They have the same construct. So like not even this, we can just like do this. I think this one will fail as well. This one shall be 4, but I think I will give a 6, right? This one. Yeah, that's the issue. Because on the right to left, as we say, if we encounter this, we don't know how to solve. So I try to go right to left, and go right to left, and we see the same thing. Let's see. So we have the left parentheses. We have identified that if we have a right parentheses, and that's a cutoff. We've done that already. It's just when we have a left parentheses, we don't know, right? We don't know. So shouldn't be if we have a left parentheses and we have another left parentheses. That means we have one left parentheses unmatched. So we record it. Like the result, the remaining shall be in the Maybe we should use recursion to do this. Every time we see a left, hold on. Every time we see a left, we enter recursion. We need to find how many is it inside. Right, we need to find the right parentheses that can match to this left. So we have a left, we say it might be a right down the line, but we don't know, so we enter. So basically we say we want to find all of these, and then there are 2 situations, right? Either we have a right parenthesis waiting for me, or we do not. Or we run it once, right? So like these are just popping out, and then we got left, right, and then we put it in a. Let me try this. Let me write this out. Maybe give us more intuition. So we have left, right, right, left, right, left, right, left, left, right, right? So what if we just run like front and back, right? So we run front, we know this position is bad, right? So we run front, we know this position is bad. So we mark it. We mark it, and then we run reverse, then we know this position is bad. So we mark it as well. And then we run it one more time from front. Let's try it. This might be the one. So we're gonna run it 2 times, front to back and back to front. We're gonna mark the ones that are not correct, right? Basically, that's our current strategy. So we still do this, but we don't count now. We just say front to back. If it's this, we're gonna append. If not, we're gonna pop. Else, we're gonna have to list equals. We're gonna do a list on this. So we're gonna do list. It's gonna be I, and enumerate. So we're gonna enumerate it, right? And then if this, we're gonna do this. If stack, we're gonna pop. Else, which means stack is empty. No, not stack. Yeah, else stack is empty, and we have right parentheses. Then we know it's a bad one. So we say list I equals. We'll put a star, right? That means that's a bad one. And then we do exactly the same. We can do J in range. Don't. Does it? I think it's fine. J letter in enumerate. We're gonna reverse it, right? Reverse it. After reverse it, same thing. We do this, else, blah blah blah. And then here we just turn it into J into a this, right? Now we're gonna run it one more time. We're gonna say res equals 0 and current equals 0, and we have a new stack. I'll put a new stack here. Stack and stack, right? Then what do? Then we say for letter in list, right? If same thing, I'm gonna do exactly the same thing as this. If letter is left, if not, pop. Then we're gonna say current plus equal to 2. Else, elif. Elif letter is right parentheses, then we know stack will always be ready. Oh, then we don't have to do this. We just count left to left, from left to right. So we count how many left we have until we hit a. Yeah, I think we can just count. If this is this, we're gonna. Not sure, but we're gonna try. I think we can just directly equals 2 because we're gonna skip the right parentheses. Okay, aleph, it's this, which is the separator. Then we say res equals max, res, and what's that? Res current, right? And then we're gonna put 1 at the end as well. So list plus, and put it at the end. It's like another sentinel at the end. And we're gonna just return res. Let's see. Ah, it's fail. Okay, that's not how it's done. Wait, hold on to this. Hold on to this. Let's just take. Actually, we're gonna leave as is. Just take a look at the list. Let's see how it looks like. 2, 1, 2, 3, 4, 5. That is interesting to say the least. I think I cannot do it this way. Well, for one thing, it should be let. And no, you cannot reverse it. So from range, len what? Len list, -1, -1, -1. Yeah? And then we say, this is going to be list j, if it's this, and then else j. Okay, so let's take a look. Okay, now we're good. Now we're good. So we say if this with plus equal to 2, if it this, done. Plus equal to 2. So it should be 4. Why you come out is 8. So this one is correct, right? And so this is this. We're gonna do max 0, 0, 0, 0. So let's do res, print res, kind of see how the result goes. So 0, 0, 0, 0, 2. Probably need, yeah, we need that as well. Yeah, let's print the list as well. So kind of compare the two. Right, so have 1, 2, 3, 4, 0, 0, 0, 0. And then we have this 0, yeah, and this is 0. Then update to 2. That's good. Then 2, 2, which is here, 2, 2, and update 6. How is that 6? Oh, I know why. Because you forgot to reset. That's why. Now we pass. Okay. Let's see how the other one's going. And of course, we have. All right, they all pass. This one looked promising. Honestly, it looks promising. Okay, let's try it. This one. Submit. Pending. Judging. Oh, we got this. Oh wow, we got this. Nice, nice. Ah, I have terrible runtime, but we got it. Wow, this made me feel very good. This is a hard question. I mean, granted, I've done it before, so maybe some corner of my mind, still has a little bit of memory on this. But I'm pretty sure I forgot. Look at this. This is October the 5th, 2018. I started doing it at 10 a.m. and the last attempt is 10 p.m., so 12 hours. I'm not sure if I've done it straight through. Probably not straight through. I think I did straight for maybe 4 hours. Gave up. Oh, I did find the solution on myself. Jesus, 1,000 milliseconds. And then at night, I think I just want to try it again. And yeah, I think that's exactly what happened. Wow, this is interesting. Yep, we solved it. Good, good. I did not expect LeetCode to put. That's what 3 hard problems in 4 days, right? Yeah, no, 5 days. 5 days. Okay, but your runtime is terrible, which means it might be possible for you to. Yeah, it is possible. I think I did one more run. So I don't have to do this one, I think. No. Or this one. One of these I don't have to do. So what we can do is we don't do this one, right? We don't do this one. We don't do this one. We do this. And after we do this, we know all the left parentheses have been marked. So we just need to pay attention to right parentheses and the mark. Oh, I can actually turn it to right parentheses. Right? If the left parentheses, oh, that might cause problem though. So we know that this means the left parentheses is problematic, which means it doesn't have a right parenthesis to match it. But if we turn that into a right parentheses, that might cause a problem. Let's just turn this into something, right? Turn to something, and then we're gonna add that to the end. What do we say? We say if it's left parentheses, we so we're sure the left parentheses is all correct. And no, we have to do it this way. We have to do it this way. Let's copy and paste this one here. Just do a little bit change, right? A little bit change. And I think we can speed it up a little bit, and we don't have to enumerate. Basically, it's the same. So we do it to list, right? And then that we append, else if stack. We're gonna pop elif. The letter is else, right? Else we say if stack, and L letter is right parentheses. Then we're gonna pop and we say res plus equal to 2. Else, which means either not stack or letter is not right parentheses, which means letter is this. Then we can update. We say we basically do this, right? We do this, and then we say this is this. Okay, let's try it again here. LE before assignment. Where? What happened? Actually, it was wrong. It was wrong. Anyway, so this is our new solution. But it's not right. It's not right. Why is that? I mean, we already identified that the comment these out. Give this a shot. Let's also gonna print our list. Just kind of gauge what happens here. So yeah, so we know this left parenthesis is wrong, right? So we come in here. We say if it's a left, we append else. It's a right. Stack. If stack, if not stack. So rest, that's still 0. 0, 0, 0, 0. Left, push in. Coming up. Right. Yeah, else. Right parentheses and stack. Pop out. Rest. Oh, rest. Current. Yep, it's a typo. Just a typo. Nothing to be worried about. Just a typo. Okay. That's still not correct. What the hell? Oh, I know why. Because we still have to add this at the end. Otherwise, it's not. Yes, now we're right. So this is only 2 times. And in fact, is it possible to not turn this into a list? No, I think we have to turn this into a list. So this I'd expect to be faster because we run it only 2 times. Only, yeah. Try it. Pending. Accepted. This one's faster. Please be faster. Oh yeah, much faster. Okay, so we're gonna disregard this. Yeah, we'll disregard this. Yeah, that is the solution. Okay. I had not expected that LeetCode would throw 3 hard questions in 5 days. I mean, for me, it's yesterday was also pretty hard. So, right, we did not expect. I have done this one before, back in October 8th, I think, 2018. I think it's 5th, 2018. October 5th, 2018. Yeah. But I'm pretty sure, but I am certain that I have forgotten the solution altogether. It's been more than 2 years. Fortunately, I was able to crack this one. The key is to identify when a valid parentheses string, when a valid parentheses string gets interrupted by an unmatched left or right paren. We do this. We can traverse the string from front to back, not front to back, left to right to identify the what? To identify the unmatched right parentheses. And then we can go right to left to identify the unmatched left parentheses. Once they are identified, we can swap them. We can swap them with a unique flag, such as the asterisk, right? These flags indicate a breakage of valid parentheses string. Of course, this algorithm can be run in one fewer pass because if we run right to left first, and then running left to right is sufficient to both identify the flag and the unmatched right parentheses. So runtime is O(n), but it's actually O(3n), right? Because we have 1, 2, 3, but we call it O(n), and we have doing 48 milliseconds, which give us 44% ranking. Okay, let's go take a look at the solution. Yep, we done it. Good. Okay, solution. This is an old question. Yeah, 32 is an old question, a long time ago. And that was when I first started doing it, back in October. Yeah, I think back then what I did was 1 question per day. And I tried to code it in 2 different languages as well. And then I realized it's not really a good strategy because it just takes too long. Anyway, solution in a stack, 10 lines. Brute force. Dynamic programming. You can do DP on this using stack without extra space. Alright. I think I might have, yeah, I forgot about all of them. Literally all of them. Let's see, what is this? O(n) tripled. Every possible non-empty even length substring from the given string and check whether it's a valid string of parentheses or not. In order to check, we use the stacks method. Okay, so invalid, invalid, valid. So we have to go O(n) tripled. Every possible substring, checking is a O(n). Okay, that's terrible. Dynamic programming. I was thinking about DP. With ith element represents the length of the longest valid substring ending at ith index. Okay, initialize the complete arrays. Let's see if you can figure it out yourself. What we're saying? What we're saying is this will be the longest valid string, right? So if this is a left, then we continue. I mean, yeah, if it's a right, then we check if the previous one is a left. We say if the previous one is a left, then we, but how about that situation? We have lots of left and then lots of right. Or you also record the current unmatched. Interesting. Dynamic programming. Can it work? So everyone initialized to 0, right? How do we do this? We start the first one, the left parentheses, that's a 0, and then we go right parentheses, then we what? So we record the left parentheses and the current unmatched. So we say current unmatched is a left parentheses, right? So we have 1, current unmatched, and then we do right parentheses, then boom, match, so it's going to be 1. Right parentheses again. If the current unmatched is 0, then that's a break. So we break. Right? We break. Left, right, we're going to be 1. Left again, right? So we left again. If it's left, we're going to extend, right? We're going to extend. And if it's right, we check if how many unmatched. We have 1 unmatched, so we previous plus 1, that's been 2. Oh, that's actually 2. 2, that'll be 4. And then left parentheses. So we extend, right? We extend, and we put another unmatched. And then left again, extend, and then we have 2 unmatched. And then right, when right, we can only match 1. So we can only do 2. Right, can only do 2. So basically, it's how many unmatched. So every time we hit a right parentheses, we going to check how many unmatched we have so far, and then based on how many unmatched so far, then like if we have 1 unmatched, then we can just add 2. But how are we going to? Well, what if like we have left, right, right? So the first right we see there are 2 unmatched, and we can plus 2. Second one, I have 2 unmatched, we're going to plus 2 again. We have to add them together. If we have a left parentheses and we have no unmatched, so we should start from 0, right? And then next one, we shall start from, yeah, that's a first left, and then we start from 0, and then we have a second left, still 0, and then we match the first one, we have 2, and if we match the second one, we're going to add it to it, so that's actually 2, right? So we find the maximum. I'm not sure. Is that a solution? We can try. I want to try dynamic programming. I just write a one solution. If it doesn't work, we're gonna go with the solution for sure. So we say dp is going to be all 0 times len s, right? And we say for lettering s, for letter in s, for lettering s, for I, letter in enumerate s. Okay, what do? We say if the letter is, so we're gonna have unmatched 0. So say if letter is left parentheses, then unmatched plus equal 1, right? And if no, let's from here. If previous we have no unmatched, or when do we start from 0 instead of copy from previously? So we can say if not unmatched, so there's nothing unmatched, then we say dpi is going to be 0. Right? Else, say dpi equals dpi minus 1, and then unmatched plus equal to 1. Else, that means letters are right parentheses, and then when I check, if unmatched, right, then dpi equals dpi minus 1 plus 2, right? If unmatched, if there's unmatched, and then unmatched plus equal to 1. If they are is no unmatched, then what do? If there's no unmatched, we just let it go. We don't change anything. Okay, so it'll be like this, and then when I return max dp. Not sure if it's gonna work. Max argument is an empty. Is that the first one? Yeah. Max this. Alright, so we can do plus 1. Len plus 1. So it's always going to be something in there. Alright. So when they enumerate s, let's start equals 1. We passed majority. We failed some. So we failed the last one. Let's take a look. It looks like, it looks quite promising, but let's print dp. Let's take a look. So this is 2. I think that's the first one. Then we have a match here. And then right is 0. Left 0. We got 2. Oh, we got left. Oh, this left we shall extend. But we say if there's unmatched, then we set it to 0. Should we extend? But if we extend here, then this one will be hard to judge. Now we actually should extend, right? But if we extend, and here will be unmatched. Oh, if there is unmatched, then we should set it to 0. No, if it's unmatched, then we should keep gaining unmatched. And then when we close, Function 0 here on the right parentheses, and we know there is one unmatched, so we're gonna. So based on previously, we're gonna add 2, right? And if it's right, and there's no unmatched, it's gonna be 0. And then with the left, right, it'll be 2. Left again, right? Left again. It depends. If it's a left again, then we count if there's any unmatched. If there's no unmatched, so everybody previously is matched. It's either like this situation or this situation. How do we differentiate the two? Well, we cannot differentiate the two. The two are the same, right? So it's basically either. So you're saying that we just extend, right? We just extend. But if we extend, that will be 4. So we extend here, that will be 4, right? Potentially up into here, it is 4. If you think about it, it is 4. It's, the DP is the maximum length of string up into this position. That's 4. So we're coming here, we extend. That's still 4. So when we close here, right? We close here. Then we find out that there are 2 unmatched, right? 2 unmatched. But I can only match 1. I can only match 1. So I say I match 1, but previously I say there are 4. How do I tell? How do I tell where I should go? Interesting. It's 4, right? And I need to know that because this will give us 2, we know, and we will eliminate 1 of the unmatched. But after we eliminate 1 of the unmatched, we still have 1 unmatched, right? That means if we still have unmatched, then we shall, do we get it here as 2? Because we say we still have unmatched. But we have another one here, right? We have another one, another right parentheses. Now if we do 2 here, it is 6, right? Because, no, it's not 6. It's not 6 because this is, but how do we know? We don't know unless we go from the other side. All right, no idea. Let's take a look. How is this considered? All right, this is, looks like more complicated than I had thought. For better understanding, let's just go this one directly. Okay. Max length is 2. That's good. Right, 0. That's what we do. 0. Yeah. 0. 0. 2. 4. That's not helping. This is an easy case. I think that this one I can pass as well. Oh, hold on. I cannot pass. It says it's a 0. Hold on. This is the special case because we can pass this. It's this one, right? This. Okay, we say it's 0 because it's a single left. Well, that's because we have a right. Like if left is always go from the previous. right? What if we have a left here? I would take this one out. Anyway, I think the case is when this, it check this plus 2 instead of checking this plus 2. Is that what it means? Okay, we have to read here. Now it's obvious this further leads to the conclusion that the substrings ending with this will always contain 0 at their corresponding. That is true. Okay. Okay, so we just force this to be 0. Yes, so we force this to be 0. If we force this to be 0, then this one solves. But we cannot solve like that problem. So we have like left, left, right, right. If we force these to be 0, this one, and so we have 2 unmatched. Right? 2 unmatched. And then this one will be, if we say previous plus 2, and this one will be previous plus 2. Huh? That's work. What if it's like this? Left, right, left, right. That is the one that might not work. We have a little 0, 2, 0. What do? We go 2 steps forward. Hold on, what are you saying? You're saying that if we have a match, we go look for, so when we have a match, so left parentheses is always going to be 0. Right parentheses is the one that we have value, right? So what you're saying is when we hit the right parentheses, there are a few scenarios. Either the one before you is a right parentheses already. So if that's the case, we can get the value from there, right? If the previous one is not a right parenthesis but a left parentheses, and that is no good, so we have to keep looking previous until we find a right parenthesis. Is that what you're saying? That every time we hit a right parenthesis, we have to keep looking forward to get to a right parenthesis every 2 consecutive characters of string. String looks like this. Okay, dpi equals dpi minus 2 plus 2. Okay, so because the ending portion is valid anyhow, and it leads to an increment of 2. Okay, that's good. And if both are right, if I dpi minus 1, then hold on. This is complicated. If both are right parentheses, when we're right and right, and the string looks like this, then if I minus dpi minus 1, so we get rid of all this, right? And minus 1 will be the one before it. If it's this, then dpi equals dp this, right? Plus dpi minus 2. Oh, okay. Okay, so right. What about right, left or right? Oh yes, either this or this. Only these 2 conditions. Good. That's good. Yeah, this is a good solution. Oh, when? Using stack. Instead of finding every possible string and checking validity, we can make use of a stack. The string scanned so far is valid and also length. For every encounter we push, for every we pop. By popping the stack becomes empty, we push the current value into the stack. Keep on calculating the length of the valid and then return the length of longest. Better understanding. Okay, let's try it. max length is 1, empty, push 2, push 3, push 4, 5, and pop. Max length is 6 minus 4. Max length is 4. Use the index. Every time we push in an index. So we just do one pass. Okay, and then for every left, we push its index. For every right encounter, we pop the topmost index, yes, and subtract the current index from the top index, which gives the length of the currently encountered valid string of parentheses. Yes, yes, that's correct. If, while popping the element, the stack becomes empty, we push the current element's index onto the stack. This way, we keep on calculating the length of the valid substring, which means, like this is invalid that we still pushed in, right? So it's invalid, or like when it's empty, we still push in. If it's empty, we always push in. If it's left, we always push in. So yeah, we are not. Hold on. So when we pop out, every time we pop, so every time we pop, we get the real length. I see the beauty of this. So we don't have to identify where the break is, because since we're pushing in, the thing we push in is the index, right? So every time we can pop, then the popped one will be paired with the current one pushing in. Then the popped one will be paired with the right parenthesis we're currently pushing in. And then, based on how the push and pop works, every time push and pop, that is a valid parentheses, including anything that's in between. That will also be valid. So when we pop, we already know what is the valid, right? We already know the value. So from here to here, we know it's the valid. And the invalid, we just leave it in there. It doesn't matter. Like we don't even have to push in this. We just say if it's empty, we just don't push. So everything we push will be the left parentheses. Good solution. I'm going to write all these after finish reading. All right, last one without extra space. 2 counters. Oh yeah. Yeah, we don't need this. We just, one is pointed to the left, the other one pointed to the right, right? And then it's the right, and then we do this, boom, pop out. And then we move on forward. This is a right, parentheses, and then the left, we can just put -1. It's -1. We just keep it here, left, parentheses, left coming here. All right, moving forward, it's left parentheses, left coming here. No. No, I don't think that's right. Doesn't seem right. Okay, let's read about it. So left and right. Start traversing from the left towards the right. For every left encountered, we increment the left counter. And for every we increment the right counter. When left becomes equal to right, we calculate the length of the current valid string and keep track of the max length substring so far. If right becomes greater than left, we reset left right to 0. Okay, let's try to take a look. No, I'm just going to do here left, right. So left is 1, right is 1. If they are equal, yes. Okay. Keep going. Left is 1. Left. Oh, left is 3. Oh, we keep going. Left is 4. Right is 2. Right is 3. So what? So I have 4 left and 3 right. Oh, we scanned it twice. Oh, this is a scan twice solution. Ah. Scan twice, we get this. And then we get another one. Hold on. I think, yeah. This. Match. Every time we match, every time left larger than right, we reset. That's a break. Okay, so this last one is similar. It goes two times. I go 2 times as well. It's like each time you go, you identify the bad one, but just instead of doing, yeah, I'm basically counting, right, left to right. I identify the right parenthesis wrong, and then we'll go right to left and identify. I go right to left first, identify the wrong parentheses, we mark it, so we can go left to right, and we immediately know when we need to break. Yes. All right, so now our job is to write the remaining. We have 3 solutions to write, which is not too bad. Not too bad. We know already how this one goes, right? So instead of doing unmatched, we basically saying there are 2 scenarios, right? 2 scenarios. One scenario is we actually need to check. So let's just do it this way. Okay. So if letter is left parentheses, that's we cannot do anything. So we just need to do the right parentheses. So as a right parentheses, we have 2 situations. Either it's right to left, or so we have 2 situations. If this is this, and and I is larger, I minus 1, larger equal to 0. No, yeah. And s I minus 1 is equal to this, right? If that's the case, then what we're saying is, oh man, this is gonna get, no, I think it will be easier if we just increment the length, and then I will be here, so the DPI will be have to be I plus 1. Or let's just start equals 1. So I is DPI, right? So if it's this, and it's fine, we don't have to check this. And then we still have the issue. Hold on. We're gonna start from the second one. Yeah, we're gonna start from the second one, because the first one is always gonna be 0. Either it's a right parentheses, or if it's a left parentheses, it's always gonna be 0. So we're gonna start from the second one. Maybe I'll make it easier. So let's say we start from the second one, right? And yeah, we start from the second one, and we check the previous one. If the second one is the left, the previous one is to the left, and then we have to start from 2, right? We have to start from 2, right? And s, I could have minus 2 is equal to this, then dpi equal to dp, dp what? dp plus 2, so at the end it's going to be plus 2, so I'm going to dp I minus 2, right? dp I minus 2. If we skip this, yeah, else this is right, and I minus 2 is a right as well, right? If that is the case, we have the right and right, and then we say dpi are equal to dp I minus dp I minus 1, all right? dp I minus 1. This is the previous one, minus 1, minus 1. Right, that's just we count how many that's in it, and we take it all away. And oh, this actually has to be minus 1. That's the left parentheses, so that is the right parentheses. Right, it's the right. So we count how many valid is in the previous. This is how many valid is in the previous. How many is valid in the previous right parentheses? Right, we know the number, and then we're gonna say from my current, we're gonna minus all these numbers, right? Minus all these numbers, and then after minus, the previous one will be invalid, will be a left parentheses. That's minus 1. That's the left parentheses. And minus 1 again, the previous one, and then it's gonna be this plus 2, and we're gonna return dp minus 1. Is not correct. All right, it's not as easy, huh? Not as easy as you think. Left. Which part we didn't do correctly? Yeah, we have to check this way, because we go from here, right? So we say letter is right, and the previous is also here. Then this is 0. I is start on 2, so 2 minus 0 minus 2 is dp 0, right? dp 0 plus 2. That's actually not correct, because if we start from here, it has to be a left parentheses for you to plus 2, right? If it's not a left parentheses, so you should not. Right? You have another check. Yes, and another check. I didn't check that. So it's going to be if this, and then like if not, right? If not, then I'm going to say if s basically is the same thing. but we have to minus 3 is equal to, but if 0, that can be minus 1. How do we reconcile that? So we need to check if that one is a left or if it's a right. Hold on, so if I'm here, right, I start from this one, and I'm going to check I minus, so this is 0, right? And I currently is 2. So 2 minus 2 is 0. So I'm checking for dp 0. dp 0 is, that'll be like complicated, right? Yeah, it's very complicated. I mean, the one thing is, because the current dp and hmm, hmm. All right, I think they do not put as different. So just have to do more checks then. That's fine. That's fine. And let's just start from the start. Right? Start from the start. And then from the start, actually we don't have to go from the start. Let's do this. For I in range 1 to len s. Right? Because the first one is always be 0. And then we're going to say si, right? If si is, we're checking this one, is a right parentheses, and si minus 1 is a left parentheses. And then we do dpi is even equal to dpi minus 2. If it could be negative, wrapping back, that's actually fine, it's going to be 0 plus 2. This is fine. I think this is fine. What is not fine is this one. If si is a right parentheses and si minus 1, right, is also a right parentheses, so like this situation, both are right parentheses, then we need to check the numbers that this have, right? So we can go to dpi minus 1, which is giving me how many this one has, and then we're going to check s. So basically we're going to say if this one is minus 2, right? So that's 0, 1 minus, this is 0, that's 1 minus, no, this, minus 1, minus 1. That is minus 1 or minus 2. I is 1, right? Minus dp 0, which is how many this has. So if I have 1, that one minus 1, right? So 2, then it's minus 2, then it's going to be pointing to whatever. So if it's if this is 0, then we're looking at itself. Otherwise, if we minus, say it's here, right? Here, here. This one is what? This one is 2. So whatever this one is, minus 1, 5, 4, 3, minus 1, minus 2, we're going to point in here. So we need to point in one previous. So I'm going to be minus this and minus 1, right? That's pointing to the one previous, right? And then we're going to do s on that. Yes, we're going to do S on that. But don't we have to check? This is the maximum, right? Where the maximum is to here. And I'm going to check this one previous, like ahead of it. Now ahead of it, if it's a right parentheses. So basically I'm saying my right parentheses need to match. Must be previous right is first right parentheses, then we'll get a maximum of its length, and we're coming out, and then go one before it, right? One before it. If the one before it is a left parentheses, then we have a matching. Then we can do this stuff. If the previous is not, it's a right parentheses, then current value will be the same as this one because I cannot match. How about anything previously? Can it match? Previously? No, because this is already the maximum that maximum parentheses, maximum number of parentheses ending at this one. The maximum parentheses ending at this one, right? So, which means if we're going forward, that must be a mismatch. So mismatch could either be a left parentheses or a right parentheses. That's going to be a mismatch. So it only happens if it's going to be a left parentheses, which means we're going to do this. If it's a left parentheses, then we have a match. Then we say dpi equals blah blah minus 2 plus 2. That's correct. Else, I think dpi equals dpi minus 1. And we're going to return. It's actually going to be max dp, I think. Oh, I got 4. Still not right, huh? So should this be like 0? Is that why it's not working? We say if it's a right parentheses, and then we'll try and look previously, and if it's a left, then we're good. If it's not a left, oh, including, okay, if it's including, that means it's going to be 0. This means we don't do this. There we go, now we pass. Max is empty sequence, FDP, else 0, almost 0, 1, 2. Okay, so left, right is here. So the first is a right, and its previous is a left. Then dpi minus 2 plus 2 has to be 2, right? And then here, oh, shouldn't be the maximum that in here. I think we should also add dpi minus 1 as well. Yeah, because dpi minus 1, and then the maximum dpi minus 1 plus this dpi minus 1. If this is a left parentheses, and then we're going from, yeah, I think that is correct. There we go. Now we do. This is complicated. Very, very complicated. So this is the DP solution from the official solution. dpi is the max number, the longest valid parentheses ending at si. If si equals left parentheses, dpi equals 0, because a valid parentheses cannot end in left. If si is a right parentheses, there are two scenarios. Yes. Either we have a left and right, or we have a right. If it's a left and right, then we look for dpi minus 2. Then dpi equals this plus 2, which means we find the longest valid paren right before the left parentheses and add 2 to it, since we now have a new valid paren. If it's this, then we need to find the letter right before the longest valid paren of the right paren in front of us, this means we need to check si minus dpi minus 1 minus 1. That's minus 1. This paren can either be a left or a right paren. The left or right. If it is a left, if it is a right, no. If it is a right, then the current right has no match, right? Else we have a match, and dpi equal to dpi minus 1, right, plus dpi minus dpi minus 1 minus 2 plus 2, which is to say we find the max and the longest paren right before the matching left. Add on top of that the longest paren of this in front of us, and plus 2. The result is the max of dp. Yeah, I don't think it's easy to figure this one out. This one is pretty darn hard. This dp solution. Oh, wrong answer. Ha. We have, I thought we got it. Should be 4. I'm getting 8. How? Say 4. Alright, I'm looking for this. This gives us 2, so I'm looking for 2. I'm looking for this, and this is not, so this one will be 0. That's 2. This one, hold up, hold up, hold up. Did we miss something here? Print dp 0, 0, 2, 4. That's good. This. This is the problem. So we are 0, 1, 2, 3, 4. What is 4? And 3 is this, okay. And then we say SI is 4 minus DP3, 0, 1, 2, 3, 4, 4, 0, right? And then minus what? So this has to be larger. So this is, let's do this. Let's do index equals this. Let's say if index is larger equal to 0 and index is this, then we equals index minus 1. There we go, now we pass. Slight hiccup. I think this, yeah, a slight hiccup. So change this and then submit. That one shall pass. Yep, this one shall pass. Oh, it was faster, 44 milliseconds. All right, keep going. We're not done yet. We have 2 more to write. Now, again, I don't think this one I will be able to figure out. The next one is, I think, using stack, but instead of, yeah, I think this one is the best one. On the stack, I put a -1 into it, and then what are we gonna do? Why do we put a -1 into it? I don't know. I actually don't know. Why do we put a -1 into it? Let's not put a -1 into it. For I letter in enumerate s, right? And then we say if letter is left parentheses, then stack gonna be append I, no matter what. Else, so the right parentheses, we say if stack, then we're gonna put a rest here. Rest is 0. Then rest equals max rest directly I minus stack dot pop. Do we have to +1? Let's see. 0, 1. Yeah, I'll have the +1. Right? So that's that. Else, if there's no stack, then we're gonna stack dot. What do we do if there's no stack? We don't have to push anything. Yeah. I don't think we need to push anything. I think this one shall be right. Let's just return rest. Yeah. This is the easiest solution. And this could be elif. And that's it. I do think this is the easiest one. The easiest solution. It uses stack and it uses stack. It handles the single right parentheses the same way as us, but it handles the left parentheses by pushing the index into the stack. The benefit of doing this is that we know immediately the longest valid paren when a right parenthesis is encountered. Yeah, so therefore, any left paren in any left paren, yeah, it won't break. Yeah, so every time we pop, therefore any left paren. Yeah, I don't know what to say. This is the best solution because in our case we have left parentheses. We don't know if there's a continuation, right? But in this situation, the right parentheses determines the maximum already because we push in the left. Yeah, I should say it that. I should say it this way. In solution one, right? In solution one, we do not know if left paren is going a single left paren is going to be valid or not. Right? We have no idea if it's going to be valid or not. Hence, we need to traverse the string twice. Here, we don't have to know because the right paren directly obtains the longest valid paren ending in the right paren. So we don't care. Therefore, we don't care about the left paren. Yeah, basically we don't care about the left paren. That is very, very smart. Okay, I am going to do something cheeky here to make it even shorter. That's going to be like this, right? 2, 3, 4, 5, 6, 7 lines. That's the 7 lines. This is the best solution. Can I memorize this solution? No, you cannot. But I think the idea behind it is when you want to compute. Oh, we got error. What the heck? Every single time, I think this must have been the same as before. Like, and we think we got it, and then they shoot us something that's that's wrong. Output is 2, expected 4. I thought that was enough. Oh, let's go with 3. Oh, you haven't run it. My bad. I have not run it. I forgot to change this to 3. And that's why I have not run it. I have multiple failures. Multiple failures. Now let's address the last one first. Okay, if it's a right, I don't care. If it's a left, right. Oh. How do I handle this? Left and right, we get it. Interesting. I think I didn't understand it fully. Yeah, what about this situation? If it's a left, we put it in. If it's a right, put it in as well. And if it's a left, doesn't make any sense. Wait, how is this situation handled? Left, right. Oh, no, this is 2. How do we... How do we handle the situation? I forgot. Now, this is a bad example for this. Okay. Huh. Else pop. Left, we push. Okay. And with the right, we pop. If it's empty, we push. So, which means we push this, and then we push, we pop, and we push, and we pop. Then I'm checking on this. Hold on. I think, okay, I think I got it wrong. I thought it was, let's do it again. We can make use of style while scanning, okay? So for value, and also the length of the longest value string. In order to do so, we start by pushing. I don't know this yet. I think it's just because if I was left or right, I think I kind of got it. So if this would push, right? If with this, we pop the topmost, but we do not subtract. We subtract from the top of the element of the stack. All right, think again. So what it means is, if I have left in, left always going to push in, right? And then we have a right. Now, if we have a right, the left is going to be something will pop out, right? That's been the matching. But the length is not is not, because if we can compute that directly, we can only do the onion, right? The onion type we can handle. But if we have adjacent, we cannot handle this. So the way we handle is when we pop the value, but we do not use the pop value. What we need to know is anything that's on top of the stack. That's the delimiter. That's the flag, and that's the anchor for us, right? If we have a single right, which means that's a wrong thing, a single right parentheses, unmatched right parentheses, that is a wrong thing. We push it in, and that is used as a flag, right? Delimiter, right? With delimiter there, and then we can always refer to this one if that's like the starting point. Yes, that's like the starting point. And if of the right and the left, right, whatever left, right, the left will all be popped out. And then when it's getting popped out, we look to the top of the stack. The top of the stack will always be the delimiter, which means the maximum we can extend our current parentheses 2. What if it's a left? That's also, oh yes, now I see. Oh, now I see. Left always pushed in. Either it's true one or it's serving as a delimiter. Right, we need to push in when it's serving as delimiter. And okay, so this is we're gonna rewrite this. A user stack. The key intuition is we need to set up the eliminator in the stack, which serves as uh, as the new starting point when an unmatched parentheses unmatched paren is encountered. Thus, if an unmatched right parentheses is encountered, we push its index in because it is the eliminator for a new start. For left parentheses, we always push its index. So it serves both as, depending on whether it is matched, its index is always in the stack. The eliminator, that is the key idea here. Still brilliant. So left, if it's right, then we're going to check if, right, so else. And now we know in the stack we have a push -1 because that's a delimitator. Otherwise, we don't have a delimitator. And that is also why we need to start from -1, since it is a delimitator as well. So when I say else if stack, then stack.pop rest equals, it's not .pop, it's stack -1, right? Else no stack.push I. This index out of range. What is index out of range? Alright, I think this had to be like this. -1, the top of the stack, because we cannot pop. Top of the stack is larger or equal to 0. I have push, append. Man, this is frustrating. I say if, hold on. So the stack, if I have a right parentheses, we don't know. So the stack, if the top of the stack is larger than or equal to 0, okay, then we pop it, and we get, after we pop it, right, we get the result. And else, if the top of the stack is smaller than 0, then I append myself. Okay, so which means when I append this, append I here, and then we do this, boom, boom, which is we're gonna pop this, and this will be 0, 2, so it should be 2, and then this 0, 0, 1, 2, 3, 4, 4, and ooh, this, this. So top of the stack. How do you know? The top of the stack, it must be a left parenthesis. I don't think they're pushing anything else. How do you know the top of the stack is a left parenthesis? I don't know. Oh, we can check, right? We can check. Yes, we can check the top of the stack. If it's a left parentheses, then we do this. And has to be, so if, all right, if this larger than 0 and s stack minus 1 is a left parentheses. And then we do, there we go, now we pass. But I still want to check the original solution. We pass everything. Do they check this? No, they do not check. They simply say we're going to left parentheses push, and now we're going to pop. They pop no matter what. If it's empty, they're going to push this in. So they pop no matter what. So when it's a right parentheses, we're always popping. That makes sense, because right parentheses is a delimiter, right? We don't need two delimiter in it. One is enough. So whenever right parentheses, we can always pop. So pop either means we pop the right one, or we pop the wrong one. So if we pop the right one, which means the left parentheses, then we should still have something in the stack. Then we can do this. Otherwise, if it's empty, then we push myself in. That means I am the new delimiter. Okay, that doesn't make sense. That does make a lot of sense. So we always pop. After pop, I'm going to say if stack, then do this, else, and do this. Let's pass. Yes, always pop. Always pop. Always pop. Because either match or it is a new delimiter. We only need to have one delimiter in stack. Yeah, there's no point having two. Right? There's no point having two. Good. I still think this is the best solution, but that does require some thinking as well. Okay. I am kind of getting lazy. I don't want to do the third one. I think that will be it. That will be it. That will be it for today. It's a good one. We solved it on our own. And yeah. It's also, but I mean, this is when it first started. Look at this, 2014. That's when it first started. Anyway, that will be it for today. We wrote 3 solutions. The DP is a little bit hard, difficult to say. And this, I think, stack is the easiest, but it still takes some mental power to get it. And my solution is actually the easiest to think through, not the easiest to code, the easiest to think through. You know, you go 2 ways and then you identify the wrong things and then we're done. All right, that will be it. That will be it. I'll see you guys tomorrow. Adios.